Reactions occur when the highest occupied molecular orbital of one molecule interacts with the lowest unoccupied molecular orbital of another, and the smaller the energy gap and the better the orbital overlap, the more likely and faster the reaction will be, with overlap patterns often guiding stereochemistry. Think of molecules like puzzle pieces made of clouds where electrons live. The highest occupied molecular orbital is the cloud where electrons are ready to move out, and the lowest unoccupied molecular orbital is a cloud that can accept electrons. If the donor cloud and acceptor cloud match in shape and point toward each other, they overlap well and the reaction is easier, and if their energies are close, electrons move with less push. For example, a nucleophile has a high electron-rich orbital and an electrophile has an empty low-energy orbital, so nucleophile to electrophile reactions follow this highest occupied to lowest unoccupied pattern. When clouds line up in certain directions, the way bonds form can favor one three-dimensional outcome over another, which is why stereochemistry often follows from these orbital interactions. A common mistake is thinking only energy matters and ignoring shape, which can lead students to predict reactions that are slow or do not occur. Always consider both energy gap and geometric overlap. Another error is treating orbitals as fixed points instead of flexible clouds that can mix and change during approach, so remember orbitals can distort and combine as molecules interact. Some learners assume frontier orbital theory replaces all other ideas, but it complements concepts like electrostatics and steric effects, so use it alongside those ideas. For more videos and resources on frontier orbital theory and related topics, check out www.gumballdegree.com.